everyone, I am Renu Sharma, Assistant Professor, EC Department. Today I am going to start with the next topic of the subject, that is wireless and mobile communication. The topic of today's lecture is Cdma, that is code division multiple access. So, these are the contents of today's lecture. First one is Cdma, then IS-95. IS-95 and Cdma is same thing. Advantages and disadvantages of GSM and advantages and disadvantages of Cdma. So, in the previous lecture we have discussed about GSM, Global System for Mobile Communication. Since it is a second generation networking system, Cdma is also second generation. We are talking about wireless and mobile communication. In wireless, all the things that we want to transmit is wireless in nature. It is based on global system for mobile communication. So, we have discussed its architecture, where mobile phone is connected with BTS, more than one BTS is connected to BSC, more than one BSC is connected to single MSC, then more than one MSC is connected to GMSC. Now, what is this BTS and MSC? BTS is base transceiver station to which the mobile phone is connected, means it is used for full duplex communication, means it can transmit, it can receive also. Then more than one BTS is connected to MSC, that is mobile switching center, and more than one MSC is connected to single global mobile switching center, that is GMSC. Further, this GMSC to this, there are different registers connected, that is home location register, visitor location register is there, that is HLR is there, then VLR, there is authentication register, and there is one equipment identity register. So, these 4 registers are connected to this MSC, where different informations about the mobile phone, individual mobile phones are collected. Then these after this GMSC, it is connected to public switched telephone network, that is PSTN, or it will be connected to data network. So, likewise this is the flow of GSM architecture, that is global system for mobile communication. After that, Cdma comes into the picture. What is this Cdma is all about? Cdma full form is code division multiple access, which means when you want to transmit any kind of information, it is first coded with some codes that is generated from Walsh tables. It can be 2 cross 2 matrix, it can be 4 cross 4 matrix, depending on the number of bits a particular user is generating, which will carry the information. Like this is Cdma, it is fully digital wireless data transmission system. It not designed for voice at all. So, basically this Cdma is used to deliver the data, means it is not used for communication purpose, means you cannot perform, you can perform this voice calls, but it is not designed for voice calls, it is designed to transmit the data. So, it uses special random numbers to encode the bits of information. Now, what is this special random numbers? These are nothing, these are PN codes. I have already discussed in my previous lectures about what is PN code. PN code is pseudo noise, pseudo random noise. This is pseudo random noise. Now, this is generated by a generator. Every time you are generating this PN sequence, it will be different. So, that is comes into the noise from that is defined as noise. It is random in nature, and the number of bits that is generated by this PN generator will be 15 bits, 10 bits, more than 15 bits, it may be 20 bits. So, these 20 bits are used to modulate or used to encode the bits of information. Let us say I have 1011 of message bit, and then it is modulo 2 added with PN sequence. Now, this PN sequence can be 10 bits, can be 15 bits. So, this is how after modulo 2 addition we will get a Cdma code, that is code division multiple access. So, now the one very important point that you have to keep in mind, that whatever PN code you are using for the first user, the same PN code has to be used at the receiver side for the first user again. Let us say, because since it is a multiple access technique, which means there are more than one user which are accessing a common channel. So, this is a channel, these are 3 users, and then the data of the individual user are encoded by different PN sequence. Let us say this is PN1, this is PN2, this is PN3. So, whatever we will get, this is added together and then it is transferred over a channel, then again it will be separated, and whatever PN code we have used, let us say here we have used PN1, then PN1 is to be used over here, PN2 is to be used over here, PN3, then it will be delivered to the respective receiver. So, this is the main point that is related to CDMA. You have to use the same PN sequence. Let us say I am using this PN1 over here, then PN1 is used at the second receiver, then whatever signal you have transmitted, it will not be demodulated correctly, it will not be delivered correctly, it not decoded correctly. So, there is no use of information, it is totally a waste. So, same PN sequence has to be used at the same user path. Now, it allows multiple access by assigning different users different random numbers on the same channel, which I have said already, like 4 users are there. So, 4 PN sequences will be required. Same PN sequence cannot be used by same different users. The only limit to the system is the computing of the base station and its ability to separate the noise from the actual data. So, it is based on the Shannon's theorem. Now, next is IS-95. CDMA is an access method. IS-95 was the first operating system to use this CDMA technique. It is invented by Qualcomm and it began its production in 1995. At this point, this is still called second generation wireless, known as narrowband wireless system. Now, narrowband and wideband, there are 2 types of systems are there. In case of this narrowband system, this IS-95 belongs to this CDMA. It is known as narrowband because the bandwidth that is used by this particular system is quite less, being supplanted by CDMA 2000, that is wideband CDMA and UMTS fully 3G system. So, they both use this CDMA, it is known as wideband system. So, you can clearly differentiate between narrowband system and wideband system. This IS-95 is narrowband and the CDMA 2000, also known as WCDMA, and UMTS, which is a kind of fully connected 3G system, this is wideband system. So, these are the 2 types of systems that comes under this IS-95. Now, second question comes into our mind, that how this IS-95 will work. So, it operates in the same bandwidth as the GSM system. So, since it is a full duplex communication, so 2 band of frequencies, range of frequencies are required. One is required for mobile to base station, which range from 1850 megahertz to 1910 megahertz, and next one is from base station to mobile phone, which range from 1930 to 1990 megahertz of frequency band. So, these 2 frequencies are allocated because wireless communication is a full duplex communication. So, channels are 1.2 megahertz, 1.25 megahertz, 3.75 megahertz in CDMA 2000 and 5 megahertz in UMTS, that is, this is for the 3G network and this is for the wideband case. Next, it results in approximately only 48 forward and reverse channel pairs in IS-95. So, adjacent cell phone towers use the exact same channels as all other towers. So, this is the major difference, allows for much better frequency reuse and makes setting up a cellular network much easier. So, this is the main some key points that is related to this IS-95. So, how this work? When a phone is turned on, it scans one of the forward channel to find a base station identifier, camps up on the strongest signal. So, what does it mean? Let us say this is a base station and this is your mobile phone. So, whenever your mobile phone turns on, or you can say that whenever you want to transmit some information, you want to initiate a call, then first this will select or this will scans for the forward channel which has strongest power, and it will cams on the strongest signal, means it will grab the strongest signal whichever channel is free. The phone sends out an encrypted pass key and gains access to the network. So, this encrypted pass key is nothing, it is a kind of PN sequence that is randomly generated, and it is known by the generator and only the receiver. No third party can find out that what is the encrypted or what will be the pass key. So, it can then sends and receive the call. It is assigned a 1.25 megahertz wide frequency to operate on. It listens for pages on the forward channel to let it know it has a call incoming. Then this is all very similar to how this GSM operates so far. So, this is very much similar to GSM this IS-95, because both belongs to this second generation network. Now, next is IS-95 vocoders. What is vocoder? Vocoder is nothing, it is a voice coding system that is generated, because whenever we want to initiate a call, we want to transfer some information in the form of this call, then voice coding system is required, which will going to encrypt, which will going to modulate our speech signal into two considering two types of sound, that is voiced sound and unvoiced sound. Then IS-95 uses extremely advanced vocoders that use variable encoding rates, just like this GSM. They operate at variable rates up to maximum of 9600 bits per second. At a minimum, it encodes 1200 bps, so that the phone does not seem dead. The quality though less than AMPS. AMPS is nothing, it is the first generation network, is much higher than GSM on average. So, however, due to the nature of CDMA, a CRC code, that is cyclic redundancy code, cyclic redundancy check code is automatically appended in order to do the error checking and error correcting purpose. So, what is the benefit of using this IS-95? That it will going to encrypt the data, and also it will going to add some CRC code, so that at the receiver side it can be checked and error can be removed also. The access method is what makes IS-95 different, it is called CDMA. So, the basic difference between this GSM and IS-95 is how you are going to access the system, the channel that is available. CDMA is a transmission technique to pass information from the mobile to the base station and from base station to mobile phone. That is the basic aim of full duplex communication. So, this is this example is showing that how this CDMA will work. Now, let us take an example that 10 people in a room are present, 5 speak in English, 2 speak in Spanish, 2 speak in Chinese and 1 speaks in Russian. So, everyone is talking at relatively the same time over the same medium, that is air. So, who can listen to whom and why? These are some of the questions that will come after this thing, because let us say 10 people are talking in different languages, then who can listen to whom, because it is not possible that the person who is speaking in English can understand the Russian language also. So, who can't you understand, or who can't speak to anyone else. So, these are some of the questions that comes into our mind after seeing this example. So, this CDMA is basically a spectrum technique, which is based on this PN sequences only. A signal takes up 6 to 10 times the bandwidth that it needs at a minimum. It seems deliberately insufficient. The military used spectrum communication, SS communication, because the signal is difficult to block. It is difficult to listen in on, difficult to even identify from noise. So, much more difficulty to tune into a certain frequency. So, CDMA is also based on spectrum technique, which is indirectly related to this PN sequence only. This is PN sequence, this is the message that you want to transmit. Then after this there is a there is a spectrum communication or the signal will be generated, then it will travel over a channel. At the receiver side again it will be modulated by the same PN sequence and you will get the message. So, this is the basic idea behind spectrum technique. There are four types of spectrum are there: time hopping, frequency hopping, direct sequence and hybrid. Hybrid is a combination of one or two different SS techniques. Now, in CDMA all the users share the same 1.25 megahertz of bandwidth. They all transmit as signals, that is the exact same size, that is 1.25 megahertz. There is actual 0.02 megahertz of a guard band, meaning that the actual bandwidth is 1.23 megahertz. This would be like 100 AM radio stations all transmitting on the exact same frequency. However, with the CDMA unique digital codes are used to separate each of the mobile phones. So, unique digital codes are nothing, these are the PN codes which will going to separate one user from another, because no two users are allowed to use the same digital code. Essentially, this makes each mobile phone speak a different language. Also, its language is very unpredictable. It starts at a random language and changes into a random fashion with a given seed. Also, the base station can speak every language as long as it is synchronized. So, each bit of conversation is encoded with this special code. So, this is the main idea behind this CDMA. So, in IS-95 the mobile and base station must be synchronized to a nearly perfect time clock. CDMA actually uses GPS satellites to obtain a very accurate system wide clock. This clock is obtained by every cell phone towers and is used to seed the code generation process. So, this is the basic idea behind this CDMA code. Now, the base station and mobile phone have an algorithm for generating the pseudo random numbers. It uses something called Walsh vectors. Now, whatever I have said that it is PN sequences generated by this Walsh table, like this is a 2 cross 2 matrix. So, whatever code you are having, let us say I want to transmit this 1 0. Now, this 1 0 matrix multiplied by this one and then a code will be generated, that will be the CDMA code. It can be converted to 4 cross 4 matrix, like this is a 4 cross 4 matrix Walsh table. If the data bits are 4 digit long, so then you require a 4 cross 4 matrix. So, this is a 2 cross 2 matrix, this is a 4 cross 4 matrix. So, these are the two Walsh tables. So, this random number generator has a very large period when they both start at the same seed. Both the mobile and base station should generate the same random numbers. The random number is actually only 32 bit long. So, it can be maximum limit is 32 bit, but it can be 10 bits, it can be 12 bits, 15 bits depending on the input bits that you want to send. This is variable in nature. So, this random number is convoluted with the data. Also, a time stamp is added, means at what time the code will be generated. So, that is very much required, because when you set a timer at the transmitter side that yes, I have transmitted the data, then in a limited amount of time you have to send an acknowledgement is to be received at the transmitter side. Is to be received at the transmitter side. If that time passes, then we have to again transmit the particular data. So, and error codes are also added, that is CRC code, which is used for error correction and detection. The result is 128 bits that represent only one bit of data. This is very computationally intense process, but modern cell phones have fast processors. So, that is why this CDMA which uses this SS modulation, this is much more encrypted data, much more suitable from the security point of view, because PN sequences are randomly generated. These does not depends on means these are different for every user. The original 9600 BPS of conversation has been multiplied to 1.23 megabits per second. So, this is a CDMA code. Now, CDMA handoff a CDMA telephone gets to decide on the handoff. This is different than GSM. Now, we will talk about advantages, disadvantages of GSM, that advantages, disadvantages of CDMA. So, GSM is mature. This maturity means a more stable network with robust feature are there, because there is nothing we require PN sequence generation or nothing like that. It generally follows the path of BTS, BSC, MSC, GMSC, then 4 registers are there, and then it is delivered to public switch telephone network and so on. So, this is very simple. It less signal deterioration inside the building is there, ability to use repeaters, the availability of subscriber identity module, that is SIM, allows users to switch networks and handsets at will. So, whenever we move from one place to another with the use of this SIM card, your mobile phone may comes into roaming, but the switching from one base station to another base station is much more simpler as compared to the CDMA, because in CDMA there is PN sequence, this is also comes into the picture. So, handoff from one cell to another cell becomes difficult as compared to this GSM. GSM covers virtually all parts of the world, so international roaming is not a problem. Now, these are some of the disadvantages of GSM are there. Pulse nature of transmission interferes with some electronics, especially certain audio amplifiers are there. It does not support some other kinds of audio amplifiers. Intellectual property is concentrated among a few industry participants, creating barriers to entry for a few new entrants and limiting competition among phone manufacturers. GSM has a fixed maximum cell site range of 35 km, which is imposed by technical limitations. Capacity is CDMA's biggest asset. So, this is the disadvantage of CDMA. Its capacity is the biggest asset, means it will going to allow maximum number of users as compared to GSM, which will allow. It can accommodate more users per megahertz of bandwidth at any other technology, 3 to 5 times more than GSM. CDMA has no built-in limit to number of concurrent users. CDMA uses precise clocks that do not limit the distance a tower can cover. CDMA consumes less power and covers large areas, so cell size in CDMA is larger. It uses soft handoff, reducing the likelihood of dropped calls. CDMA's variable rate voice vocoders reduces the rate being transmitted when speaker is not talking, and it has a well defined path to higher data rates. So, the main summary you can say of the CDMA, it supports larger number of users with greater security, and it high data rate it will provide, and it supports soft handoff. These are some of the disadvantages of CDMA. Most technologies are patented and much must be licensed from Qualcomm. Breathing of base stations where coverage area shrinks under load as the number of subscriber using a particular site goes up, the range of that site goes down. So, since when number of users will be increased, so this there is a disadvantage that the quality of the signal that will be delivered when the number of users are larger is quite less as compared to when the number of users are lesser, means lesser the number of users, higher quality of the signal will be delivered. So, currently CDMA covers a smaller portion of the world as compared to the GSM, which has more subscriber and is in more countries overall worldwide. So, these are the references that you can consider for today's topic, which covers CDMA after we have discussed this GSM, and it has showed some advantages and disadvantage of the GSM as well as the CDMA. So, GSM belongs to the second generation network and CDMA belongs to the third generation network, which supports larger number of users as compared to the GSM. So, thank you.